Hello. Okay, so the purpose of this video is to basically show you some formulas that can be used for exponential growth and decay. All right, so if you look at these two formulas, actually, the only real difference between each of them is the sign in the middle. Okay, so the plus sign here will represent growth, and the minus sign would represent decay. Okay, so basically some terminology here. So f of t would represent your final amount. The constant a would represent your initial amount. R would represent either your growth rate or decay rate, depending on which formula you use. And t would represent time. Okay, so another way to actually represent this, so this is basically b. So you know, like what I was showing you earlier in the other examples, this is actually b. And this a in front here, that all that will do to the function is basically vertically stretch or compress it. Okay, but don't worry about that for now. I'll discuss that later. But basically, all you got to worry about is the b. Okay, so basically, if the expression inside is greater than 1, this is going to represent exponential growth. And if the expression in here is between 0 and 1, this is going to represent exponential decay. And that's described here. Okay. But anyway, let's go ahead and read this particular word problem. Okay. So it says a certain stock opens with a price of 59 cents. Okay. Over the first couple days, the value of the stock increases. So here's a keyword. The keyword is going to be increases. Okay. On average, actually, maybe I'll put that in a green color. I'll put that in a green color. Increases, because that's good, right? So increases on average by 50% per day. Okay. If this trend continues, how many days will it take for the stock to be worth $6? Okay. So let's try to think about what we have here. So it says a certain stock opens with a price of 59 cents. Opens, that represents our initial amount. That's A. So that's going to be 59 cents. Okay. Our rate is going to be how much is increasing per day. So that's going to be 50% per day. So our rate is going to be 50 divided by 100. So in other words, that's 0.5. Okay. And we're trying to figure out, well, if this trend continues, how many days will it take? So days, that's what we're trying to figure out. We don't know time. Okay. Will it take for the stock to be worth $6, which is our final amount? That's what we're trying to figure out. So f of t is going to be $6. Okay. So let's use this formula. We're gonna use the exponential growth formula. And the reason why is because the problem says that this is increasing, right? So because this is increasing, this represents exponential growth. Okay, so now what we're going to do is we have 6 equals 0.59, 1 plus 0.5 raised to the power of t. Okay, so let's add 1 plus 0.5. So that's 0.5. So this is going to be 1.5 raised to the t. Okay, now you might look at this and figure, okay, how the heck do we solve this kind of thing? Okay, well, in order to actually solve this algebraically, I'm gonna have to teach you this, teach you about logarithms, but we haven't even gotten there yet. So one way we can get around this is we can use Desmos. Okay, so so this is a little exercise where you're actually going to have to use Desmos. Okay, so if I show you here, so we have, let's try to break this up into two parts. So if we have the left hand side here, we can graph the line y equals 6. And we can also graph the right hand side. We can also graph y equals 0.59 times 1.5 raised to the t. Okay, so this is where you're going to have to use Desmos and try to figure this out. Okay, so let's go ahead and graph each of those things. So let's graph the line y equals 6. And, I don't know why it's taking so long. There we go. And then the other graph is y equals, okay, and then we're going to have to put 0.5 0.59. And then multiplication, so I can put a parentheses, so I can press shift 9 for the parentheses, 1.5, close parentheses, shift 0. And now if we want to raise an exponent, so raise to some exponent, we need to press shift 6 for the caret and just raise to the power of, we could put like this keyword, yeah, so we can put t, or you could put x if you want to, if that helps. Okay, so based off this, we're trying to look for a solution. We're trying to look for a solution to these two equations. So the solution to these two equations can be found if we just click on the intersection point right here. Okay, so the intersection point here says that, well, if t equals 5.72, then y is going to equal 6. And that's basically how we can answer this question. Okay, if we round to the nearest hundredth, this means t is going to be approximately 5.72 days. Okay? And that's generally how you would solve something like that, if that makes sense. Okay? So let's go ahead and look at another example. Okay? So this one, it says the value of a truck. Let's see if I can fit that. I think I can. Okay, so the value of a truck purchased new for $28,000. Okay, so that's going to be our initial amount. So purchase new for $28,000. That's our initial amount. A equals $28,000. Okay, keyword is decrease. Decrease. I'll put that in different colors so you can see that. Decreases by 9.5% each year. Okay, so that's, well, this percent is going to tell us that's our rate. So this is going to be 9.5, and we divide that by 100, and that's going to be 0.095 if we convert it to a decimal. Okay, our goal is to figure out, well, how many years will it take? So we don't know time, which is in years. How many years will it take will the value of the truck be worth $5,000? Okay, so that's going to be our output. That's what we're trying to figure out, our final amount. When does it reach $5,000 after decreasing in value so much? Okay, so what we have, the keyword is decrease. Okay, so since the keyword is decrease, we're going to use exponential decay. All right, so rather than the first example that I showed you earlier, right? So the first example I showed you exponential growth, we use the plus. For exponential decay, we're going to use the minus. Okay, so let's go ahead and use the minus. Okay, so maybe I'll write this up here just so you guys can kind of see what we're dealing with. So we have f of t equals a times 1 minus r raised to the t. Okay, so basically, if I come down here, what we have, so this is going to, so f of t is going to be 5,000 equals, and then a is going to be 28,000. Okay, and then we have 1 minus, and then we have 0.095 raised to the t. Okay, so what we're going to do for this is we're going to have to use Desmos again. Okay, so Desmos says we're going to have to split this up into two parts. Okay, so we have the left hand side. So if we use Desmos, we're going to graph y equals 5,000. And then we have the right hand side here. So if I simplify the right hand side, well, this is y equals 28,000. Let's see, what is 1 minus, let me see what that is really fast. 1 minus 0.095. This is going to be 0.905. So I'm just going to go ahead and write this here. So this is going to put 0.905. And we're raising this to the power of t. Okay, so what we want to do with this is we're going to go ahead and calculate what time is. Okay, so this is where we're going to have to use Desmos again. Okay, so Desmos. So oops. So if I do this, so I just change this. So y is going to equal 5,000, and the other one, let's see, instead of 5,000, we have 28,000 here. So 28,000 and times 0.905. Okay, 0.905 raised to the t. Okay, now you might look at this and be like, well, Mr. Chang, where's my graph? Where can I find my intersection point? Okay, so you're gonna have to use these options here. So you see you have like a zoom in or zoom out. We have to zoom out a little bit. And as you see, if we zoom out far enough, we might be able to find an intersection point. So we're gonna have to zoom in a little bit, and we need to just click on the intersection point. So what it looks like here, if I click on the intersection point, that's going to be about 17.259. So that means after 17.259 years or so, the value of the truck is going to depreciate to about $5,000 or something. So that's basically what that's going to be. So about 17.26 if I round to the nearest hundredth years. And there we go. Okay, so that's generally how you would do that type of problem. Okay, I'm going to show you a few more just to help you out, and I'll see you next video. Okay, bye. Hello. All right, so let's continue. Okay, so let's say for this example, so it says on federal income tax returns, self-employed people can depreciate. So let's underline that in red. Depreciate is going to represent some sort of decrease. Depreciate the value of business equipment. Okay, suppose a computer valued at $2,765. That's going to represent our initial amount. Okay, so A is going to equal $2,765, and this depreciates at a rate of 30% per year. Okay, so our rate in this case is going to be 30 divided by 100, and that's going to be about 0.3. Okay, our goal is to determine the number of years, so that's our unknown. We don't know our unknown, how many years it would take for the computer's value to be $350. So our output, our final result, we're trying to figure out when the computer is going to cost $350. Okay, so as you can see here, well, depreciates, well, is going to represent some sort of decrease. So that represents exponential decay. Okay, so now what we have is we're going to use the formula f of t equals a times 1 minus r raised to the t. Okay, so let's go ahead and plug some of the things that we have in here. So this is 350 equals a is going to be 2,765, and then we have 1 minus r is going to be 0.3, raise that to a power of t. Okay, so like I told you earlier, basically what we're going to do is we're going to use Desmos. Okay, so in order to use Desmos here, we're going to consider, we have the left hand side. So left hand side is going to be y equals 350, and then we have the right hand side. So if we have the right hand side, so this is y equals 2,765 times 1 minus 0.3 is going to be 0.7, and we raise that to the power of t. Okay, so basically what we're going to do is we're going to have to use Desmos in order to figure out, well, how many years it would take for the computer to be $350. Okay, so let's go ahead and do that. Okay, so we have y equals, we had 350, okay, and the other one, so we have y equals 2,765 times 0.7 raised to the power of t. So you might look at this, be like, okay, Mr. Chang, I still do not know where my graph is. What does my graph, where does my graphs intersect? So this is where you have to play around with the plus and minus options here. You can zoom out or zoom in. So let's zoom out a little bit. Okay. So as you can see here, if I zoom all the way in, we're looking for the intersection point. So the intersection point here, this represents t. So this means this is going to be about 5.795 years or something. Or if we round, maybe round to the nearest tenth or something, this is going to be approximately, so 5.79, so about 5.8 years. Okay, so this is how long it would take a 2,765 dollar computer to be worth $350. So about 5.8 years later. Okay, right. So let's go ahead and look at this last example. So this last example, what we have, it says Sue has a lamp from her great grandmother. Okay, she has it appraised. Okay, so appraised, that's going to be something positive, and finds it is worth $1,000. So that's how much it's initially worth. Okay, so that's going to be $1,000. Okay, just ignore that for now. She wants to sell it, but the appraiser tells her the value is appreciating by 8% each year. Okay, so that's going to be our rate. Our rate is 8%, so 8 divided by 100 is going to be 0.08. Okay, so what we want to do with this is want to figure out, well, in how many years? So how many years? So that's what we're trying to figure out. Will the value of the lamp be worth $2,000? So in other words, so f of t in this case, we're trying to figure out when the value of the lamp will be $2,000. Okay, so appreciating is going to be something positive, right? So appreciate, or basically an increase, that's going to represent growth. As you can see, the value of the lamp is going to get more over time. So the formula that we're going to use is we're going to use the one with the plus instead. So a times 1 plus r raised to t. And I apologize earlier. I think I forgot to write that formula earlier. So I apologize for doing that. But the first example, so you see the one, let's see. The one, I guess, if you go more up, the other example, you'd use this formula for growth. But anyway, let's go ahead and just plug things in. So we have 2,000 equals, a is 1,000. And then we have 1 plus 0.08, and we raise that to the power of t. Okay, so I have 2,000 equals 1,000 times 1.08, because 1 plus 0.08 is 1.08, raised to the power of t. Now we're going to use Desmos. Okay, so we're going to use Desmos to try and figure this out. So on the left-hand side, we're going to graph the equation y equals 2,000. And on the right-hand side, we're going to graph the equation y equals 1,000 times 1.08 raised to the power of t. Okay, so this is where we're going to have to play around with Desmos and figure out the intersection point. So we just change it up. So y equals 2,000. Another one is 1,000. And we have it multiplied by 1.08. 1.08 raised to the power of t. So let's go ahead and zoom out a little bit. And aha! So as you can see, as we're zooming out, we use that minus sign and a plus. We're going to zoom right into our intersection point. Okay. So our intersection point that we see right here, that's going to be our answer. So looks like it's going to be about 9.006. We'll just round it to nearest hundredth, 9.01 years in that case, I believe. I think that was the context. Yeah. So this means, well, t is going to be approximately 9.01 years. Okay? So that's how long it's going to take for the lamp to reach $2,000 that you see there. So it's going to take 9.01 years for it to from $1,000, it'll be worth $2,000 later. Good money. All right, and that's it. Okay. So please let me know if you have any questions on this at all. And I'll see you later. Okay, bye.